Hi, I'm Ishan Sharma, and as many of you might know, Kobe Bryant and his daughter Gianna is no more. They died in a helicopter crash, and I was so shocked with this news. The first time when I saw it, I could not believe it. I was like, sure, this must be a fake news. But then later on, when I looked up, it came out to be true, and I was so shocked about this, and I just couldn't believe it. Like, for me, he was like the last person I would ever expect something so unfortunate to happen. He was just such a great person. He was hugely talented, and he worked harder than ever before. He used to get up at 4 o'clock every single day, even after he got retired. And recently I was listening to his podcast interview on the School of Greatness by Lewis Howes, and I was really motivated by his. The first time I listened to him, I was in 11th grade. I was having a hard time with JEE preparation, and his ideologies and perspective of life really moved me. Like, he was just such a kind person, and he was honest, he was kind, and I mean, this is just really sad, guys. And I hope you will pray for his daughter Gianna and for his mother Vanessa, for the 3 girls Kobe left behind who lost their father, and their sister, and for his friends who were on their flight with him, and the pilot and the other people who died. This is just really sad, and for me, he was like a bright light against the darkness, and that's just how I want to remember him. Kobe, I will miss you. Alright, now moving on to this week's episode, we got Sharad Chitlangia, who is a Harvard intern, and he's already worked at startups, and he really is an amazing person. We talked a bunch about how did he got into machine learning, some of the obstacles he had to go through, and it was just a really good talk. I hope you guys will learn something from it. Let me know what you think about the episode by reaching out to me on social media at Ishan Sharma 7390, and also share this with a friend who you think needs to know about this episode. Okay, now let's just get on with the episode now. Welcome back to a brand new podcast episode. I'm Ishan Sharma, and you are listening to BITScast. This is episode number 9, and today with me I have Sharad Chitlangia, who is a third year right here in BITS Goa, pursuing electrical and instrumentation engineering. He's a machine learning god, and
I'm not doing electronics at all.
Okay, and I'm also co-hosting with Harish Kumar, who came onto my podcast for episode number 4. I hope you all will enjoy it, and let's get started. Hello, Sharad, how are you doing today, man?
Really good, because I just woke up.
You just woke up, feeling good, huh?
Yeah.
Ready for the conversation?
Yeah.
And Harish, how are you?
I'm pretty good. I just came back from Panjim.
Yeah, man. You had a nice lunch.
Yeah. Mojo Bar.
Mojo Bar. So how's it going, bro? Like, how's your third year, second semester, and your second year, second semester going on?
Third year, second semester, it's almost about to end.
What are your impressions?
Electronics is almost about to end. That's the good part.
How do you feel?
Mixed feelings, I guess.
Feelings.
That's what I'm saying, right? Electronics is ending. That's what I'm happy about.
Was it as monstrous as it was documented by your seniors?
I don't know, because none of my seniors actually told me that, it'll be like so hard or something.
Oh.
I mean, it's definitely hard.
You had the better part of seniors.
Yeah. I don't know. Actually, most of my seniors were, at least the seniors who I was, talking a lot to, they were pretty much involved in ML and AI since the start. So, pretty much like me.
Same here, man.
Nice. That's nice.
And Harish, how's it going with you?
My semester?
Yeah.
It's pretty tough. I'm usually super busy, a lot of extra classes. In fact, there was an extra class for one of my humanities. Who really cares about humanities? Yeah, so 2-2 is way more busier than my 2-1. And yeah, I mean...
What's your branch?
EC.
Oh, yeah.
So I just feel I should go back to my first year when I was like super free and just chilling with friends. Miss my first year though.
This semester is different because I'm actually attending classes.
Oh.
You're finally attending classes.
Yeah. I mean, I've finally realized that, okay, just 1 week studying before the exam won't,
So you had a lot of time in the first and second year. What was your journey
Yeah.
like in machine learning? How did you get started with machine learning?
Pretty much, some CTE courses. I took some CTE courses. My
So
first
you do
year.
believe in CTE, like it's not a scam or something?
It's a good, it's
It's a good scam.
It's a good scam.
Yeah, it's a good scam. People used to call it scam in our year. I don't think it's like a scam anymore because they, make their expenses and everything public. I mean, you can obviously make changes to that and make it public, but...
Just changing a number on the Google sheet.
Yeah. But still, I think what's good about it is that it gives you a push in the direction that you want to explore.
Gives you mentors too, right?
Yeah. Honestly, like, I don't know. I mean, deep learning, there was this course on deep learning on campus.
Mm-hmm.
The instructors were not so good. Like,
Okay.
But I mean, it's fine because they're students, first time teaching, whatever. And there was this course on reinforcement learning in CTE.
Okay.
And those instructors were the best. They were probably better than even most of our professors.
Okay.
Students.
Yeah.
Students were better than the
Easily.
professors.
Easily.
Oh my god. What courses were they taking? Like,
Huh?
what courses were they taking? They were like all CS231 from Stanford and stuff.
What courses had they taken?
Yeah, like.
I'm not sure, but in our year, they were like the gods.
Okay. And
So
now you're the
name
one.
few.
No.
You're not.
So there's this guy, Wazir Zulfikar,
Okay.
Mhm.
Sebastian Santi, Sahith Dambe Kodi,
Mhm.
and Preetham
And where are
Reddy.
they right now?
Wazir did his thesis in MIT.
Okay.
Oh,
Wow.
man.
Sebastian Santi went to he did 2 GSoCs, like consecutively.
Second and third year?
Yeah.
Oh my
Second
God.
and third year. Second year with Mozilla.
Oh.
Oof.
Okay, it's
And
pretty
third year
hard,
with?
right?
Julia.
Julia.
It's pretty hard to get
Mhm.
selected for that because so many people apply for that. And then with third year GSoC in Julia, he was also at UCL doing a research internship.
Mhm.
And then he went to CMU for a research internship.
Mhm.
And now he's at Microsoft Research as an AI research
Oh.
fellow. I'm
Sebastian
telling you,
Santi.
it's like the toughest thing to get selected.
And what was his
as a
branch?
Electronics instrument
Electronics.
and instrumentation.
Is it like most of these electronic students end up in ML? Like every single time I go through people's like ML people's LinkedIn profile, they're usually pursuing electronics engineering.
The thing with CS people is they have too many options, and that's what keeps them hanging around somewhere. I don't know. The thing with electronics people is at some point in your first year you know that if you don't
Yeah.
buck up your asses and do something, you won't get a job.
Mhm.
Yeah.
Even in electronics.
Mm-hmm.
Yeah.
Nowadays that's not true because some companies even come for internships. Last time they came, this
Yeah.
time also they'll probably come. Anyway,
Mhm.
so at that point it was not like that. So I think it's just about that, right?
Mhm.
They have choices. They have a lot of
So you're
things
saying
that-
like for electronic students,
they're spoiled
and-
with choices. the CS
Oh, they have to
Sorry,
be
yeah.
things to do.
Continue.
so for electronic students, you're saying ML is like an exit point. It just helps them, get a job straight away. Or like even they have choices, right? Even they can get into web development and all the other options.
Yeah, definitely. So if you see Sandy's profile, he was actually more of a software developer before than ML research.
He was
Mhm.
into what, web development or app?
Yeah, like I think pretty much everything.
Oh,
So,
everything.
Yeah. So
And what was the
he developed,
CGPA?
I think 7, something above 7.
Does
Oh.
CGPA matter?
CGPA does matter.
But not for him because.
Yeah, for
CGPA
people like him.
I think it matters, but so I don't think he would have gotten selected as a research fellow
Mm-hmm.
if he had a CGPA of less than 7.
So you're saying if anything's above 7, then
For
you're
electronics.
free to
7.
choose and explore different fields.
I think if you're above 8.5 in electronics, then you're safe. But it's too hard to be
Exactly.
above 8,
Mhm.
8.5,
Especially in
after 4 years.
electronics.
Mm-hmm.
Especially like, I think most people will see a drop in their CGPA in 3.1 or 3.2,
Mhm.
but it'll
What courses are
probably
the hardest in like? Are they
it'll probably increase at the end because of PS2 or thesis. Anyway, yeah.
Mhm.
So electronics, I think electronics and communication does not have power electronics, and even I haven't done power electronics right now. I'm doing it.
Mhm.
But there's this course called analog design, analog and
ADVD?
analog and VLSI design.
Oh,
Mhm.
everyone hates it, bro.
I'm telling you, the average of that course was 55 out of 200.
Oh.
And like I think one of our courses before that had a NC, what do you call it?
Threshold.
Of like 40. So if that was
Wow.
exactly if that was true in I don't think it was true in ADVD,
Okay.
but
They
if
had
it
to
was,
drop the NC threshold in
Exactly.
that case.
I don't know what
It
exactly
had happened to like one of our courses last semester. We had something called ED, and even
Yeah.
its AB was around 50 out of 200.
Yeah, so ED,
So I think
MUE,
they-
ADVD, they're like in the same lot.
Yeah.
How did you get your Harvard internship?
Oh yeah, you studied at Harvard.
Yeah, so okay, I'll tell you. So first semester I did, those CT. I never attended those CT classes. I went for like one class in I think 3 classes.
Mm-hmm.
But
Instructors were not good.
yeah, so I went to the RL one every class
Mhm.
because it was too good.
What project
So-
did you make? Was it like the Atari 88?
No. I didn't think I could. So 2 people in the end completed the project, me and Ajay, if you know.
Mm-hmm. Yeah.
So,
He was playing badminton or something.
Yeah.
Table tennis over there.
so what happened was later on. So actually, I used to do online courses for these things. CS231 I used to do for deep
Stanford's
learning,
course.
and RL I used to do the Udacity one
Mm-hmm.
because there wasn't. I don't think the course by David Silver or Sergey Levine was there then. Anyway, coming back
Mhm.
to that. Okay, so I did those courses.
Yeah.
Then I think SAIDL had just formed.
Who was the founder? Were you the founder?
No, I was in like the
Co-members.
initial members.
Okay.
But I wasn't the founder.
How do you like make a club here in
Here?
BITS Goa?
We are unofficial, so
Okay.
we're not official.
It's
we
like
don't
that
need to
anime
be-
club, huh?
Yeah, we don't need to be official. We don't need anything.
Yeah, exactly. You aren't
Okay.
associated with the admin,
Yeah.
so it doesn't matter.
So the founders were Pranav Garg and Alish Dipani.
Okay.
Okay, so Alish was I think in second year only, right, at that point, so he did not know much, but he knew probably more than any second year, right?
Mm-hmm.
So I think the initial members were me, Pranav,
Mm-hmm.
Alish, then there's this guy Mehul Rastogi,
Mehul Rastogi.
then Aviraj Hinge,
Mhm.
sorry, and Rizul Ganguly. So we were
Mhm.
like the 6 people were there initially. So what happened was Pranav at that time knew a lot. Probably, he knew everything, state of the art, everything. So he told us to do a project on speech accent transformation. Basically,
Okay.
Mm-hmm. Let's say I take your speech and I want to transform it. Okay, let's say we take my speech and we want to transform it to the accent that you have
Mm-hmm.
at
Whoa.
the starting of the
Yeah, that is
Podcast.
possible. That is
yeah,
possible.
exactly. So that's what the project idea was. But then what happened was this was actually a research idea at that time.
Mhm.
Nobody had published anything on this. So Baidu Research actually came up with their own system for this in February.
Mm-hmm.
So what we were planning, we had to drop because they had
Mhm.
already published. So what we instead did was just implement that paper.
Okay.
So neural voice cloning was our first paper.
Mm-hmm.
Then I did an internship in a startup. Then
With startup?
its name is Unfound.
Oh,
Yeah.
fake news.
Fake
Yeah.
news,
detecting.
misinformation
Yeah.
detection.
Right, that one. So yeah, it's
How was the
it's
experience like in there?
pretty good, I think. I mean, they
Does it have a
treated me
BITS
pretty good for a first year ride, I think.
Does it have a
because-
You were
BITSian founder?
first year right when you were there.
Yeah.
Does it have a BITSian founder?
No.
Okay.
They treated me pretty good for a first year, right? Because obviously I did not know NLP, a lot of NLP at that time. So what happened was I used to so it was an unpaid internship, obviously.
Yeah.
So I used to go there, and I think the first week at least, I used to just watch CS224N videos. And then I used to, I mean, not like the whole day, just then, just watching CS224N. I used to experiment with their, they had a database of all their articles which they had collected. So what they essentially, so they would build on that, first they have to collect a database. Then, so I used to experiment with that. So first few weeks was that. Because I had nothing to do, I did not know anything. So then what happened was, I worked on this task of basically switching their information retrieval system from like something that's syntactic based, essentially.
Can you see that in simpler words?
Yeah, that's what I was trying to do.
That's what I was trying to do.
So semantic means, the word meaning.
You can understand it.
Okay, like what does the word mean in the sentence? But syntax means
the normal grammar, like
no, not that, and also just the just the general
structure of it.
Yeah. So so that was a bad, because if you're not able to capture the meanings of a word, so you won't be able to get the proper meaning of the sentence in the first place. So essentially what the first thing that we did was just take like embeddings of the words, just average them out, and you have a representation of the sentence. And then we used to do this for the whole document by averaging that out. And then if I had a query, let's say Hindu, what's that, NRCCA or something. Sorry. So I can type that in.
Yeah.
And it would create an embedding for that, and it would try to match it with that. And if it had a score of, let's say, some threshold, greater than some threshold, then we would put that in the retrieved articles.
Okay.
So we used to retrieve 5 articles through this way, and then we had a very complex system for the top article. So that's a bit hard to explain. But anyway, so I switched this. Then what happened was these embeddings called ELMO came. So ELMO stands for embeddings from language models, I think. So that was like the state of the art in NLP that time.
Okay.
And so it's actually from Allen AI. It's a research organization in University of Washington, I think. And so at that point, when I used to read that model, when I used to read the paper for that model, it was, I always used to think, how can people even, beat this? This is such a complex system. So what we did was we just used ELMO embeddings. ELMO embeddings, basically, rather than just converting a word to its word meaning, it would pass it through a deep network and then produce an embedding. So that's how it got better. And it had this contextual thing. So let's say you have 2 words. You can say I'm playing the guitar, or I'm playing cricket. So although they mean the same thing, that you're doing some activity or whatever, but they have like very different contexts, right? So essentially it would help in that, the ELMO model. It was really good at that. So we just switched the information retrieval model. We wrote our own scripts for ELMO. We fine-tuned it on our data sets and everything, and then we deployed that on an API. So that's what we did.
Okay.
So at that point we used to think, how can ELMO cannot be beaten, it's so good. And then I think 3 or 4 months later came along BERT. BERT.
Okay.
BERT. And BERT has been like the standard for around 2 years now.
Yeah.
And improvements that you can see on top of BERT will only be, by such a small score. So let's say there's this model called XLNet, and why it why it's better than BERT is just because they had massively trained that model on around 512 TPUs. Do you know what TPUs are?
No.
Okay, TPUs are custom. So they're like GPUs, but for neural network training and inference. Okay, so they're like a specialized chip. That's why it's called ASIC. Okay, now TPUs are made for that, and they're expensive as shit. Like they're so expensive. I think it's around $24 an hour or something. I don't know. I'm not sure the exact number. Yeah.
Okay.
So they had trained it on 512 TPUs for I don't know, a very long time or whatever. So yeah, massively pre-training that, and then they got some. So essentially, BERT is now like the standard since 2 years. So okay, yeah. Coming back to that whole internship. So I did that internship.
Digress to some other
Exactly. Like a tangent.
Yeah, so I did that internship, and then I came back to one and I did some projects. One of them was on autonomous drones.
Yeah.
So why I'm telling you all this, it's kind of connected because when I was at Unfound, we used to read a lot of articles to understand what's happening with the system. So I got pretty interested in drones, and because I think people testing out reinforcement learning on drones and autonomous drones just started then. NVIDIA, so we actually had an article on this NVIDIA drone trailing along forest trails or something.
Okay.
So that's what got me interested in this project, and then we did a project over here on that. Like it was essentially just replicating what we were doing. So
like
what
did
they
you
were
approach
doing, what they were doing. Huh?
Aerody for that?
No. It was totally without them. Anyway.
Okay.
So we pitched it to this EEE department, and they have these fundings for projects.
Oh.
I think around 20,000 or something for one semester. So we used their money to buy some hardware, and we also got that institute funding thing, which is around 50,000. And so we didn't actually use that 50,000. We only used I think 20,000. So our total budget was I think around 40,000. So we got. So why we needed that was. First of all, we need the drone, 11,000 rupees. Then we need, there's this, what's it called? Yeah, NVIDIA Jetson. It's like a very small GPU based computer. Do you know Raspberry?
Yeah.
So it's like Raspberry, but with an NVIDIA GPU. Okay, so now what the thing with that is, it has a development board, it has a total carrier module, but it's very, very heavy. So we needed a custom carrier module which was not heavy, because if we put something really heavy on our drone, then it won't fly for a long time. So we bought that custom carrier, and it was actually I think around 9,000 rupees, but then it was coming from the United States, and I think when it reached over here, I got an email saying that you have to pay 4,000 rupees or else as duty, or else we won't let it pass or whatever. So I had to pay that. So I think if there was some way to cut off this 15,000 rupees cost, we could have, but at that time we couldn't. So we just got that. We made our drone, and we were making the software and the hardware parallelly. Okay, we were like 5 people. I was leading them. So 2 people on software and 2 people on hardware. One of them was in Aerody, one of them was in ERC. One of them is working for the rover project.
Okay.
So they knew, things. The thing, what happened was, one of our rotors would always run faster than the others. So when we were trying to, fly it, it would just, go like, you'd be making some sort of jalebi in there. So we actually never got to test our models on the drone, but we could see in simulation that it was working pretty good.
Okay. What software did you use for that?
So, what's the name? I forgot. We obviously use ROS for the basic thing, but ROS has this basic simulator. What's the name? Gazebo. Yeah.
Mm.
So Gazebo we used just to see if the like our raw system is working or not.
Mm-hmm.
But to do the actual system, test the actual system, we had to run on AirSim. AirSim is like Microsoft's custom environment generator and
Mm-hmm.
those things for these kind of autonomous things like
Alright.
drones, vehicles, cars. You can put your drone and then you can create whatever environment you
Mm.
want. But it's primarily for drones, air sim.
Okay.
So we had to test. We tested on that. It was working. But so what I think, like when we started, our goal was that we could record a wicked video and then post it on our websites or GitHub.
Mhm.
Okay, this is our working model.
Mm.
But we could never do that because it never actually got
Yeah.
working because it was doing that weird thing. So long story short, it was working, but we had
Yeah.
no way of showing it was working.
Mm-hmm.
Except for the simulation.
Yeah. So what happened was, so then essentially, what I thought was, okay, I'll just post the code on GitHub. Let's see,
Mhm.
whatever happens, we'll see. So I posted the code on GitHub, and then because we were like, so our model was also only like deep learning based, like
Okay.
totally. So let's say we'll feed an image to the model, and
Mhm.
it will just tell us the actions.
Mm-hmm.
Oh.
Like take a left, take a right, take right, or go straight. So how we would take left or right is turn the drone by 45 degrees and move forward.
Mm-hmm.
Mm.
Like what was the
because you
purpose
cannot-
of the drone? Like when you say autonomous drone, like what is its ultimate
Or
purpose?
like delivery
How
or
does it
stuff.
maneuver?
Yeah, you can do that.
So
can
you
do.
say this is point A, this is point B, go whatever path has.
It
that
was
has
actually
least
more
obstructions.
towards So NVIDIA I think did this project because I think they wanted to sell it as, let's say, people who want to trek
Mm.
want their videos recorded or something,
Mhm.
so they can use this.
Mm.
But I think this
Autonomically
exactly.
called
So this has applications. This has a lot of applications in mine, like exploring
Mhm.
underground mines and all those
the-
things.
Mm.
If you can couple this with low light imagery,
Mm.
and
Mhm.
Exactly.
so you can do those things.
Yeah.
It's essentially helpful for things that humans cannot do.
Can be used for like Amazon deliveries.
It can be. I think Amazon is already like testing them a
Yeah,
lot.
just testing it out. Do they use a similar technology?
We don't know.
Cool. So I'm like
Yeah.
closely related.
One second, yeah, sorry. So then what happened was, since we were facing that problem of so we were only using deep learning, right? And
Mhm.
we never found this so do you guys know about OpenAI Gym?
Yeah.
So OpenAI Gym is like a library
Mhm.
for training deep reinforcement learning agents.
Mhm.
So what you do is you create an agent.
Yeah.
What
What's
you have
deep reinforcement?
Deep reinforcement learning is so let's talk about reinforcement learning.
Yeah.
What reinforcement learning is, I have an environment, I have an agent, and the
What's an
agent
environment and what's an agent?
environment, I'm telling you. So environment is like the world.
Okay.
Okay, yeah.
You create an artificial world, that's the
Mhm.
environment. Agent basically is an entity who has a job to do in that environment. Okay. And how will the agent figure out what to do in the environment?
Mhm.
The environment has rewards fixed
Yeah. Exactly.
in itself.
The more
So-
you walk, the more you
Yeah.
something like that.
So basically, what happens is the agent takes some sort of action. Basically,
Mhm.
I input an action
Mm-hmm.
to the environment, and then the environment will tell me how good is that action. It will tell me what the next observation is,
Mm-hmm.
and basically, your agent should be dependent on the
Mhm.
the observation. So you feed the observation into the agent, and it will tell you, okay, what action should I take?
Mm.
And what the environment will do is in turn take that action and tell you back how good that action is
Mm.
and what the next observation is. So let's say for this trailnet example only, like trailing the forest on some trail. Okay, so you have a drone. You put it at the starting point, and you're training some sort of deep reinforcement learning agent. Okay, So what? Let's say you're taking random actions at first. It'll obviously be that because your policy and everything is untrained. Okay, policy is like how you're taking actions based on observations. So you go ahead, the environment tells you this is right. If you go left and there's bushes on the left, it'll tell you that this is bad. So you get a negative reward. And your next observation is you're just looking at bushes. And obviously, if you're looking at bushes, you don't know what to do. You cannot see a trail.
Yeah.
So this is bad. This is bad experience. I don't have to do this. This is what the agent understands.
Okay.
And then it will not do this. And then it will go straight. And this is how it learns. Okay.
Yeah.
Why are you laughing?
Why would happen?
Nothing. Continue.
Anyway. You can tell your audience.
The way you're explaining it is like...
What?
No, nothing.
Anyway.
Is it too simplistic?
No, it's fine, right?
Anyway,
You have to
continue.
oversimplify it.
Yeah.
right?
Should I?
No,
Now
this
it's fine.
is
It's fine. It's
oversimplified.
fine.
This is
Okay.
this is the best flow I can get.
So the thing with so what happened at a point was I realized that there's no, like a complete loop controller based simulator for drones. Essentially, that you have some environments for drones, and then you take actions, and the environment tells you, okay, this is bad, or this is good, whatever. There's nothing like that. It did not exist till then. So I saw that project on that professor's page,
Oh.
and I just reached
Who
out
was
to him.
in Harvard?
Yeah, so I just reached out to him that I was doing this project, but
Just
I could
Mhm.
never find this. But it seems from your project that you have some sort of framework or library.
Mm-hmm.
So he told me that they had built a library, and this is their preprint for the paper,
Mm-hmm.
and it was under review at a conference. So I told him that would you be willing to discuss about this or whatever. So yeah, he said he told me yes, but it was like I think 2 or 3 weeks in because apparently
Okay.
his schedule was too busy,
Mhm.
which is understandable.
Yeah.
But I was like really glad, and I think the time we agreed upon was I think 1:30 or 2.
Oh.
Mhm.
So in any case, we kind of discussed whatever things they were
Mhm.
doing and
Yeah.
what I had done, and then I just asked him that, okay, would you be willing to, would it be okay for me to do an internship like this summer or whatever?
Mhm.
So then he said, he got confused for a minute, but then he said yes.
Okay.
And-
He got confused.
Because that wasn't like the original
Okay,
plan
okay,
of the
okay.
whole
Yeah.
thing, right? So,
He
but
directly pitched him
yeah.
internship.
So the internship was unpaid, just by the way.
Okay.
Yeah.
Okay.
It was unpaid.
Yeah.
Oh.
So, and that's because I asked him in like mid-April.
Hmm.
So even we weren't sure that, would I
This
get
would
my
work or
visa
something. Okay.
by the time, because my start date at that time was May 15th,
Mm-hmm.
and getting US visa for
It
an
takes time.
internship
Yeah.
in 1 month is
No, it takes time. It's not
Impossible.
tough for us,
Yeah.
It's
especially.
pretty tough for like internships and jobs.
J1 visa. It's probably the toughest visa to
Yeah.
get because they don't want.
It's more selective than Harvard.
Yeah. No, definitely not.
Pretty sure the rejection rate is quite high.
It might be, but not.
It's lesser than 5% for sure.
Yeah, but
Harvard
Harvard
has a
selection
selection
rate
rate-
might be too low. Anyway. So yeah, that was the whole.
Yeah.
But yeah, so since we did not know, I'd have also applied for GSoC. So
Mhm.
and that apparently I got that, and I had zero expectations of getting that.
Yeah. Talk about GSoC for
Yeah.
some time.
For
Tell
a
me,
for a
what was your
first year or a
experience?
second year right who's listening to this, how do you get into GSoC?
The GSoC actually first year, I think it's a bit hard unless you started coding,
It's
before
like
first
5 years ago, there was a first year right who got GSoC.
Yeah, there was this guy. I don't remember his name, but he got I think he got directly placed in Apple or something in Europe or somewhere. I don't know, but he had done GSoC in first year.
Okay. Mm-hmm.
So yeah, even I know a guy in
Pilani campus. Yeah, I know him.
Yeah, so he did his GSoC in first year. Now
Pradyuman
he's in,
Ban.
I don't remember his name. I don't remember his name, but I think now he's in Facebook Menlo Park,
Oh,
and it's only his fourth year. So
that guy
Yeah.
is in second year right now.
GSoC can definitely put you places
Mhm.
easily. For a first year, right, if you do not know coding, I think it's a bit hard to get
Yeah.
it.
Mm-hmm.
Mhm.
I think
It's too
I
much
mean-
of.
What
Pressure
exactly
is-
is GSoC? Like a lot of people confuse it between competitive coding, but it
Yeah.
not exactly competitive coding. Can you
so
just clarify? that?
GSoC, essentially what happens is you get selected to contribute to an organization.
Hmm.
You get selected based on
Yeah.
your proposal.
Hmm.
So, and then what happens is you have to work according to your proposal.
Hmm.
If you, whatever, so usually they have some sort of problem that they want students to work on.
Hmm.
They're not as hard as the ones they work on, and not as easy as the ones which they tell beginners to work on.
Hmm.
But the key thing to understand here is that beginners, solving issues in a massive code base for beginners is very easy usually.
Hmm.
Obviously, it takes time to understand and navigate your way
Yeah.
through the code base,
Hmm.
but it's not that hard. But working and implementing and changing something in the code base as a university student for a very large organization, and they accept that change,
Hmm.
this is a huge thing. Which
True.
Yeah.
because so even let's talk about
Was it?
the project that I had.
Hmm.
So
You went into research organization, right? And that's
Yeah.
even harder than like
I
Mozilla
mean-
or something.
it's actually, I don't know. I think I kind of find research and software development organizations to have the same kind of work, but
Hmm.
as in obviously what you're doing at the end of the day is different.
Hmm.
Like you do have to research when you do the software engineering part as well.
Mm-hmm.
So it's not that much different,
Hmm.
but yeah. So usually research organizations can ask you to implement a paper or whatever
Hmm.
into their system.
Okay.
So mine was to essentially port the already existing solutions and make it library safe. Essentially, not library safe. That's no word, but so I mean I can use technical words, but I don't want to.
Mhm.
So one of them is like thread safe. Thread safe is essentially if you're doing multi-threading, then you
Mhm.
don't want processes from different threads to
Yeah.
get like intertwined or
Mhm.
whatever.
Mm-hmm.
So yeah, these kind of things you have to take care of. So yeah, this was a research project, but I mean it was a research organization, but I don't see much of what people expect from research
Yeah.
to be happening in that project.
Hmm. How did you choose CERN?
I mean
Particularly?
it was pretty easy for me. I was working on the project that proposed. I was working on that since 5 or 6 months already. So, and I think the other guy who applied for that
Mhm.
project, not the other guy, I think the other guys who
Guys.
applied
Yeah.
for that project,
Hmm.
they had forked my repository to show their work
Oh.
on GitHub. So I think like when I was applying, I was kind of okay. You know what? I think I'm in a good standing to
Yeah.
get this project. But then I kind of forgot in the middle. So what I told them was
You forgot about GSoC.
yeah, because for a month you don't know what's going to happen.
Oh.
How early did you start for into the code base? Like talking with the mentors.
Code base. I did not even start. So usually it depends on what task they require. So
Mhm.
they require you to do. For me, it wasn't anything related to the code base.
Mhm.
But usually they do require, people to go through their code base or whatever.
Yeah.
For me, it wasn't. That's why I started looking at the code base after I got selected.
Mhm.
Mm-hmm.
Like the
So-
general advice is like you have to start early enough so that you can
Yeah.
build a relationship with the mentor,
Right.
so that
because-
then you can leverage that afterwards.
Yeah. But that's after you know things in
Mm.
general. So
Mm.
if you start coding in first year,
Yeah.
I think it's pretty hard to get in first year. Unless all you do every day, what you do is just coding
Yeah.
and different projects, different competitive coding or machine learning, everything.
Mm.
You're just doing that every single day.
Yeah.
Then it might be possible. I'm not saying it's not possible.
Mm-hmm.
So what are the prereqs for GSoC?
I
It
think
depends a lot. right?
honestly, I mean,
At least in your case.
like I'll speak generally. I think you need a good understanding of object-oriented programming in at least one language.
Mm-hmm.
I did not know in C++. I knew in Python,
Mm.
but I think the
You
mentors.
didn't know
were-
Python?
I knew Python. I
Okay.
did not know.
Not C++.
Yeah. Okay. Yeah.
I knew basic C++. Everybody knows
Yeah,
int, main,
everyone.
blah blah
Yeah.
blah, printf,
C
whatever.
and C out.
Yeah. So, C and C out. Sorry. Anyway, so later on, so what happened was the mentors were kind of okay with me not knowing C++ as much
Mm-hmm.
Mm-hmm.
because I mean I knew Python a lot
Mm-hmm.
because I had written a lot of classes and all those things in Python.
Methods and classes.
I mean that's not the end of OOB, but I had done a lot of OOB in Python because so it was pretty clear from my GitHub projects because most of them required multiple classes, multiple
Yeah.
files, multiple those things.
Mhm.
So I think that's what the reason was for them being okay about me, not
Like
knowing
what sort
C++.
of projects did you work on using Python?
I had a lot of mini projects.
Which are the ones that
What's
you're
your
most
favorite?
proud of
Yeah.
Okay.
at that point in time?
So there was this. At that point in time, I was very proud of neural voice cloning.
Okay. Yeah.
The only problem in that project is that we never actually had. So we had to actually train our model on, I think, like 820 GBs of data.
Wow.
820 GBs.
Yeah, and we could obviously never do that.
Yeah.
We had this shorter 18 GB data
Hmm.
that we just trained it on, and like kind of overfitted the model and just posted that on GitHub. So, I mean, it was kind of a hack, but
Where did you train
It
it,
was-
on? Like Kaggle or something?
no collab.
Collab.
We had no
okay.
credits, nothing.
Mhm.
There's this Kosambi GPU over here, but the CUDA libraries that they have in that is like now it's probably even 6 or 7 years old.
Oh my god.
Oh.
Maybe like the first or second generation of CUDA. Not
Here in
not-
campus?
Not that old. Yeah.
Okay.
Yeah, but so essentially that.
Hmm.
Let's talk about that later because I think the campus is getting a lot of upgrades, I think.
Okay.
Anyway. So neural voice cloning, number one.
Hmm.
Um,
Did you use PyTorch or TensorFlow, or did you just
PyTorch, because TensorFlow it was 1.0 that time.
Hmm. Right now it is like 2.0.
TensorFlow
It's a lot
versus
better.
PyTorch. What's better now?
Now
TensorFlow.
it's
For a beginner
actually
to
the
get
thing
started
is
right now?
for a beginner to get started,
No,
definitely PyTorch.
Okay, and then later on as you move forward?
Yeah, you should learn TensorFlow because TensorFlow is really good. Just the fact that it's so there's this thing about, I don't know if you know about static graphs and dynamic graphs.
Mm-hmm.
So PyTorch builds it graphs and all the execution and everything for that language in C++ in dynamically.
Hmm.
But TensorFlow does that statically. So there's a set variables of graphs, and that can only exist unless you make some sort of way to change it.
Hmm.
That will only exist. And why that's good is because it's much faster, and there's a lot of reasons. It's much faster than you can do if you want to export the model and compress it and deploy it on a model.
I heard like PyTorch is easier to learn as compared
Yeah,
to
PyTorch
TensorFlow.
is much easier to learn. The documentation is really good. But
Yeah.
TensorFlow documentation sucks.
Oh.
It sucks
It's not even
so
like
bad.
updated, I think, for 2.0.
Yeah,
Some things are
yeah.
not updated.
So TensorFlow, is bad in that sense. But if you want to be like good in ML and if you want industries and everyone to recognize that, then you should definitely learn TensorFlow.
You are doing right now in TensorFlow, right? For
Uh,
the current projects that you're working on.
No, but yeah, I mean I do both now. So it's
Mhm.
not
Mhm.
TensorFlow or Python. So, but yeah, if I want to like prototype, if I'm like checking some sort of algorithm or is what I'm proposing, is my hypothesis true or
Mhm.
whatever,
Mhm.
that I definitely do in PyTorch.
Oh.
because I'm just so comfortable with PyTorch right now. PyTorch is very Pythonic. TensorFlow, it feels like you're writing another language.
True.
Because as a first year, you cannot understand TensorFlow or tf.session.
I was just
what is
using
a
Keras
session?
and stuff.
Exactly. Yeah.
If you've done, a CA student from third year can understand it very well, because TensorFlow is very compiler based. You know, this thing about sessions, execution, all these things exist in compilers basically. So what do we do in, so you guys must have written C++ codes, right?
Yeah.
You write the code, then you compile it, then you execute it. That's what TensorFlow does. It'll compile, it'll send it to like C++ format, and then it'll execute that or whatever. So it's very, very much like compilers, but compilers is, there's a reason it's a 3-2 course.
Yeah.
Okay.
So yeah, TensorFlow 1, even TensorFlow 2 it's definitely good, but at some point you need to understand these details about.
Okay.
Yeah, but the thing with PyTorch is it keeps deep learning first, and it keeps up with the expectation that you're writing Python at the end of the day.
How is machine learning different from deep learning? A lot of people seem to
Deep learning is like a
between-
subset of machine learning, right? If I'm not
Yeah.
wrong. It's like multiple layers.
Right. Deep learning is, nowadays I think deep learning has become its own category. But
Yeah.
deep learning is essentially, this is like
Huge
the most
topic.
argumentative question right
Yeah.
now. Because I think crazy number of people are arguing about it. Even like the Turing Award winners, except one of them. And so deep learning, in my opinion, is just these deep models which exist, things like neural networks, which have like layers of perception or whatever. There's obviously different models. There's Boltzmann machines and all those things, but that also come under deep learning.
Transformers are coming up recently.
So yeah, that's neural networks only. Boltzmann machines do not, they have altogether different way of learning than neural networks. So yeah, so I think like when you have like layers of perception or understanding, then you can call it deep learning.
Okay.
Because you're kind of building hierarchical features at different levels, and that's why you can call it deep. And machine learning is just machine learning is such a generic term. It kind of applies to anything that's smart.
Linear regression. Okay, so let's go a little bit off topic. So I work closely with chatbots. What are your views on chatbots? Are they really helping businesses?
It's really hard to answer these questions because even when you have data to answer these questions, you can like correlate different things with different answers. So the thing with chatbots is they're obviously helpful, but they're not they cannot exist on their own. That's what I'm saying.
True.
Yeah.
So someone would talk to a chatbot if let's say if they're having a problem on their whatever software or whatever.
There's a chatbot I recently was looking up to. I don't remember the name, but it was like you talk to it. It's like a friend of yours. It's like an app that you talk to. You tell that I had a bad day and my friend ditched on me or something. So and then it's like, okay, fine. And then it remembers that.
Yeah.
And the next day it'll again bug you like, hello, how are you? What happened today? Something.
Yeah.
And people get hooked to that.
Right. Exactly. So yeah, chatbots. You need a prior, first of all, to build that chatbot upon. Once you can have that prior, then yeah, it's kind of helpful. It's definitely like helpful to have like an automated service rather than calling the call center.
Yeah. So you're saying a hybrid between humans and chatbots is the best combination for say customer service.
Yeah.
And
for customer services where they require a human.
Yeah.
So let's say you're a media organization. People often they can talk to chatbots. They can use a chatbot just to throw some updates on
Exactly.
the
Mhm.
products or whatever.
Updates
There you
on
don't need a
news.
human.
Yeah.
But yeah, for customer service, all those things, yeah, it should be a hybrid.
Yeah. And what are your views on voice bots like maybe Alexa or Google Assistant?
So views, like, what are you expecting?
Going forward into
This-
the next decade.
Do I see them as, like,
as the next big tech, as the new revolution, as a new internet?
I think the level of understanding and perception that they're reaching with voice bots and chatbots right now,
Mm.
it'll be kind of hard to supersede that.
Mm-hmm.
So it will definitely. So now it's the job of software engineers to put them in some sort of package to,
Yeah.
if it's very very sellable,
Mhm.
and that's only because software engineers or research engineers can point out the good things about that
Mhm.
and make it into a really good product.
Mhm.
If they can do that, and so that's what will separate them from generic voice bots or chatbots.
I think like if you can have like say I'm like, okay Google, I want a lawyer, okay, and the number one lawyer that it picks up,
Yeah,
the guy gets it right.
yeah, exactly.
So that is a field
So-
that is coming up.
Right. So that actually requires a lot of software engineering.
Mm.
People think that okay, the machine learning model might have just predicted that or whatever, but
Mm.
it's a lot of software engineering. So it's definitely, so it will probably be voice bots. I mean, they might whatever explode or whatever, but
Mm-hmm.
the reason they might explode is probably software engineers doing their job really really well. Because I don't think voice bots will get a lot better, at least in the next 10 years.
Why do you
I
think
don't know
so?
if I did. Because
There's a limit to competition or something.
this is, no, not that. Probably because the level of, intelligence that we're reaching with voice bots or
Mhm.
chatbots, it's kind of,
Saturated.
yeah, it's kind of saturating. You can
Mhm.
definitely have something that's, really,
Mhm.
really well, really, really better, sorry.
Mm.
Mm-hmm.
We can never predict that, but
Yeah.
I think so even the complex models right now, let's talk about chatbots. The most complex model that you can use behind the chatbot is BERT.
Mm-hmm.
Mm.
But to better BERT, you need crazy amount of understanding of NLP
Mm-hmm.
and machine learning in general and deep learning. But that does not come so easily.
Mhm.
Because if it did, people would have beaten and bettered BERT
Yeah.
already.
Mhm.
But it's been 2 years and BERT is like industry standard, research standard.
Okay.
What are some of the applications of deep learning that you are looking forward to? Like you are really enthusiastic about those?
Probably the most that I'm excited about is climate change.
Climate change.
Yeah, I'm working with one of the professors here on that, but
Mhm.
it's very interesting. That's what the thing is. With climate change, you cannot, just directly say that. Okay, so for image classifiers, it's very simple.
Mhm.
Not for image classifiers, which are trained on like simple dogs, cats, or whatever.
Yeah.
They're like very simplistic and
Mhm.
okay, this is an image of a dog. Oh, classified,
Mm.
whatever. But with climate change and satellite imagery and
It's a
all
lot
those
more
things,
complex.
Yeah.
the problem is much more complex. You
Mhm.
cannot just classify something. How can you
Mhm.
classify something? You can do something like mapping trees
Mm-hmm.
or something, but then it requires a lot of human work as well before.
Yeah.
Mm-hmm. So there was this project that I saw from a Stanford guy. I think his name is I don't remember his name. Anyway, so his project was essentially, so what they did was they mapped satellite imagery to some sort of information that they scraped from Wikipedia
Okay.
Mhm.
locations.
Mhm.
So that's very very intelligent of that person to do it
Mhm.
in the first place, because okay, let's say you have some satellite imagery data.
Yeah.
How do you label this? How do you annotate this? You cannot. It's too hard.
if we have previous images of hurricanes and stuff, like
Yeah.
then we might be able to predict it.
Right. That's one thing.
Hmm.
So what I'm saying is, generally, let's say you have an image of a city or something. Let's say even a farm or a
Mhm.
state.
Hmm.
You have lots of images of it, and you want to do something on those images. It's not that easy. It's not as easy as telling, building a data set like cats versus dogs,
Hmm.
because there are a lot of
Yeah.
factors to consider.
Mhm.
So the thing is that solutions in these domains are very intelligent, and they require a lot of thinking, because things are not that easily available
Mhm.
in this domain especially. But I think deep learning generally it's very interesting to see when people apply it to new things in
Mhm.
general, because it's very general. Wherever you have a complex
Yeah.
system, you can replace it with a neural network.
Mhm.
That's probably better if you have the data.
It's recently been applied to racing, Formula One racing,
Yeah.
to tell them if they should pit or not
If it's the optimal time to
Yeah,
pit
yeah,
on.
yeah. using reinforcement learning.
Yeah.
But tell me a little about your recent that quantum reinforcement learning paper that you got published today.
Quantized.
Right? Quantized.
Yeah. Quantized reinforcement learning. The paper is about what can you do. Essentially the paper answers, does reinforcement learning when you have very resource constrained
Mhm.
devices or chips or whatever.
Okay.
So because let's say you want to send a drone into a mine or something,
Mhm.
to do some sort of task. Let's say,
Mhm.
okay, there's some human stuck, you want to find him.
Mhm.
You cannot have a drone just run for 15-20 minutes, right? So plus the environment is very resource constrained in the first
Yeah.
place. So the thing with quantized reinforcement learning is we kind of answer the question that when your drone is very, very small and it does not have a lot of energy,
Mhm.
battery basically,
Mhm.
does not have a lot of compute, does not have something like NVIDIA Jetson.
Yeah.
It relies on typical RAM,
Mhm.
CPU, software. How can you kind of, extend deep reinforcement learning algorithms in those
Mhm.
domains?
Recently,
So-
TensorFlow Lite is also coming up.
Right. So essentially
and
what we
Arduino.
do is we just use quantization
Mhm.
and we kind of better the whole scenario. So now it's
So
using
you're making
4
a
times.
qubit or something.
No, this has nothing
What
to
does
do with
what
quantum.
does quantized mean then?
Quantize essentially means, let's say you have a signal.
Yeah.
Okay. Now you can quantize it by taking, points on that signal. So to represent that whole signal,
Mhm.
rather than having like a sampling rate of 10,000 hertz, you take only specific points on that whole signal to represent that whole signal.
Okay.
So how does this apply to deep learning?
Mhm.
Essentially, you take the neural network weights, you convert them from FP32 precision to int 8.
Mhm.
So now your memory usage is 4 times less.
Mhm.
And if you're lucky, then so there's this L1 cache or cache basically that exists on every processor.
Yeah.
If you can fit that model in your cache,
Mhm.
the memory usage is so less just
Mhm.
because it does not have to access the memory. It's on cache. So the memory usage is very, very less. So that's what we kind of show. If you can fit the model in your cache by some sort of compression or quantization or reducing your memory, then
Mhm.
it's really helpful. And yeah, so the thing with this another advantage this has is that since it's on your cache, it's much, much faster. So there's this concept of control loop rate
Mhm.
in a drone. Essentially, how much there's a whole control loop, right? You take an action based on whatever.
Mhm.
So how much time is that taking? So we kind of increase the control loop rate to I think around 18 times if we can fit it on cache.
Mhm.
But that's generally variable for different chips. Yeah.
Cool. So before we wrap up, how do you manage so many things? How does
Yeah,
a day in
exactly.
the life of Sharad look like?
I don't attend lectures, first of all. I used to not attend lectures. Okay, I'll change
Recently
that.
started.
Yeah.
Why
No
was that?
lectures at all?
I mean, I have to maintain my CGPA. That's all.
Yeah,
Thank
but
you.
your what is the CGPA? If
7.64 right now.
7.64.
Decent.
It's decent.
You
but
want
yeah,
to get like 8
8 plus.
8 plus.
8 plus. Yeah,
And you can still get that much. Like you
Yeah.
can increase that much.
I can, but let's see.
And then how does your
Might
day
not
look
be
like?
practical.
So
Do you sleep?
obviously.
Yeah, realized
So
it.
yeah, usually till now how it worked is not attend lectures, but obviously I attend labs and all those things because they're compulsory and they're marked.
Mm-hmm.
But labs would usually the good thing with BITS is that if you can prepare really well for your quizzes,
Yeah.
all those things, then you kind of
The small
know,
things add up.
yeah, you kind of know what's going to happen in the mid-sem or the compre or whatever, because they structure the quizzes that way. But last semester I totally messed that up and I did not do well in the quizzes, and therefore I did not do well in mid-sem and compre. So so yeah, this sem it's somewhat, yeah, I kind of attend lectures.
Mm-hmm.
Then I think it's pretty much just what I kind of want to work on.
How much time do you devote to reading research papers? And what resources do you use for researching for papers?
Resources, it depends a lot because there's no
For the thumbnail.
oh, okay, yeah, so resources, it depends a lot on the what the project is, because I mean there's obviously, I usually just Google things,
Mm-hmm.
but usually the thing with me right now is that I still have obviously a lot to learn. So usually I would start by, so I have a Twitter account where I follow like 500 or 600 researchers,
Yeah.
Whoa.
and they post, you get at least 3 papers
Okay.
from every day from those guys.
Every day they are releasing.
Someone might
Mhm.
basically you get 3 or 4 research papers for a day.
Okay.
So that's what I start off by.
Mm-hmm.
Then it would be other things.
Okay.
Let's say if it's something related to the project, I just usually Google.
Mm-hmm.
Google works pretty well.
Mm-hmm.
I
Works
don't-
well for every programmer.
Yeah, I've done that for my whole of GSoC, so I know.
For someone who's starting off in machine learning, would you recommend to use PyTorch or start from making a neural network in plain Python? PyTorch.
Definitely PyTorch.
Then why do you recommend me to make it like from scratch, neural networks?
That's because that's so that you understand what's happening.
Yeah, so you should do that, right?
I mean, I thought you were asking, for a beginner who wants to, just experiment.
Yeah, I'm a
with these
beginner.
things. So I don't know. So your goal was to learn, right?
Yeah.
That was the whole point of the assignment.
Mm-hmm.
So that's why we wanted,
Mm-hmm.
So usually we don't have these questions. Usually, we have this NumPy neural network question,
Mm-hmm.
and we have a harder question, and we have like a third, some question which is different. This time we had all 3 questions different.
Mm-hmm.
None of them required to use NumPy, just NumPy. But why we did not do that was because I think there's probably more than 1 million repositories on NumPy neural network.
Okay.
So, I mean, yeah, we can obviously test the guy for
Mhm.
knowing if they know or not. But I think the optimizer study, if one could have done that, if someone did that, then we definitely know that
Mm-hmm.
he's really good because he spent the time on doing that.
Mhm.
Because even for, I think, us, we'll probably take like 4 or 5 hours to do that. It's definitely easier because you've dealt with all those
Yeah.
optimizers, but it takes time to. So that was the whole point of the assignment.
Mhm.
Continuous hard work.
What is your future plans like after graduation?
Most probably, like, definitely research.
Research. Where do you see yourself in 5 years?
But probably pursuing a PhD.
Okay.
Probably.
Mm-hmm.
We never know though.
You won't go for placements.
No, most probably not.
Mm-hmm.
Even if I'm going for placements, it probably might be for a research based. But in any case, placement unit won't let me sit because of my CGPA.
Oh, because you're?
Because of my CGPA.
Why?
Oh.
I think they have 8 as their
Placement unit for placements.
yeah. I mean, if you're an electronics student and you want to sit for CS,
8 is the...
that way.
Okay. Yeah, but you can score it, right?
let's see,
If you...
let's see.
yeah. Fingers
We don't
crossed.
Yeah, the thing is, this time I have a few relevant courses. But
Did you
if
get the CDCs for
minor in data?
Yeah,
science?
yeah.
No.
You did.
If you're an electronics student, then you cannot hope to get them. You cannot rely.
Even after having a good PR.
Yeah. No, you don't get an option.
Oh. There's no option for choosing for...
Yeah, so the thing with neural networks and fuzzy logic and machine learning, those two courses are that they're taken by CS faculty.
Yeah.
So they have their, control over who will get to do them or whatever. But that's what I don't like. The registration is pretty messed up. Anyway.
Wait, so the machine learning course, anyone can take it, right?
You can sit in the class, I think. I sat in a bunch of
So
classes.
in our 3-1, what happened was the CS guys did not have a lot of electives to take. So what they did to solve that problem was that they took the machine learning and NFL courses, which are even disciplinary electives for electronic student, and made them into CS only courses. So basically that electronic student cannot take it. So yeah, that's kind of problematic. So that's what the thing with being in electronics is, that you have to look out for yourself. CS, there's a whole department looking after you. I mean, yeah, obviously even the EEE department looks after you, but I'm talking about the people who want to change fields or whatever,
True.
like myself.
Okay, Sharad, thank you so much for coming for the podcast.
It was amazing having you. Good luck for Sadel. Hope it goes to new heights.
Oh yeah, by the way, why is Sidle so unknown in the campus?
Is it?
Why don't you build a hype or something?
It's such an elite club.
Yeah.
The thing, we don't want
It's like
to,
the secretive club that has some...
Why do you want us to build all that hype?
I don't know, more people
Then
will...
we have to just review more applicants.
Yeah.
We want to keep Saddle only to people who can,
Competent people.
basically...
People that are willing to do research.
Yeah, and spend, daily efforts into doing what they're doing. So, most people in Saddle, I think they're putting really good effort. So, I think 2 guys have given interviews for MIT, 3 guys have given for CMU. And yeah, that's just...
And they got that just by sending emails to professors.
And having good projects in the first place.
Yeah.
So, when you're applying for research internships, your CGPA won't matter. Especially through email.
Okay.
I'm talking about only through email. Like the unofficial way. If there's an official portal, then your CGPA will be definitely looked at.
Yeah.
But if you're applying through email, then the only thing that will matter is the projects that you have and what you did in that project. So, and I think our campus is not particularly that well equipped with professors to, do or guide people on this. So, and that's why it kind of requires a lot of hard work. So, the whole point of Saddle being so
closed and...
Yeah, not so, I don't know, very...
like GSoC and...
Yeah, basically, up in the audience or whatever.
Yeah.
Is the fact that if someone wants to pursue AI or ML so bad, they can obviously do on their own.
Yeah.
But they can obviously come to us because we are similar and like-minded people.
When are applications opening up?
Summers. We have one assignment in winter and 1 assignment in summers.
Yeah. Alright, Harish. Thank you so much for coming.
He got in our outreach group.
What is that group
we'll
about?
train you now.
Oh,
And once you're trained, if you're good,
you train my model.
we'll train you, we'll give you tasks, and once you can do that, then we'll take you in.
I hope to join it soon. That was my agenda for this year.
Yeah, I saw your out of context.
Where did you? Yeah, out of context. I wonder why don't they put my name in there. I wouldn't mind it. Okay, Sharad, thank you for coming.
No problem.
So that was Sharad Chitlangia and Harish Kumar. I hope you all enjoyed this episode. Again, let me know what you think about it by reaching out to me on social media at Ishan Sharma 7390. And yeah, I mean, I had a lot of fun with this interview. And all right, I'll see you in the next one. Bye-bye.